When we look beyond Mars and Saturn, we find Neptune, the eighth and most distant planet from our Sun. Out there, nearly 4.5 billion kilometers away, Neptune orbits in the cold, dark reaches of our solar system, a mysterious world that has fascinated astronomers for generations. Far from being a frozen, quiet sphere, Neptune is a dynamic, chaotic giant where the laws of physics play out on a scale that challenges our imagination. Its deep blue color hints at the wild, ever-changing storms that rage across its surface, with winds reaching speeds faster than any other planet in our solar system. Its discovery was a triumph of mathematics, predicted by observing Uranus's odd orbit before anyone saw Neptune itself. This remarkable achievement showed that human intellect could reach out and find worlds hidden in the darkness, using only the subtle clues left in the dance of the planets. Neptune is more than a planet. It's a testament to human curiosity and our drive to understand the universe. Every observation, every calculation, and every mission to study Neptune brings us closer to unraveling the mysteries of our cosmic neighborhood. This world is a laboratory for studying planetary formation, with supersonic winds and a churning atmosphere unlike anything on Earth. Its storms, some larger than our entire planet, reveal the raw power and complexity of nature at work on a grand scale. There's no solid ground, just layers of fluid and gas, forcing us to rethink what a planet can be. Beneath its clouds, Neptune hides secrets about the formation of our solar system and the diversity of worlds that exist beyond our own. In this journey, we'll uncover Neptune's brutal environment, its shape, and its role in defining what it means to be a planet. We'll explore how its gravity shapes the orbits of distant objects and why it remains a source of wonder for scientists and dreamers alike. Neptune isn't just a distant dot, it's a key player in our cosmic story. Its presence helps sculpt the outer solar system, influencing comets and icy bodies that drift in the darkness. Let's peel back the myths and discover the true nature of this distant blue world, a planet that continues to challenge our understanding and inspire our quest for knowledge. Neptune isn't a frozen ball of ice, as many might imagine when picturing the distant blue planet at the edge of our solar system. Nor is it a solid world you could ever hope to stand on, like Earth or Mars. The idea of setting foot on Neptune is pure science fiction. Neptune is classified as an ice giant, but in astronomy, ice refers to volatile compounds, water, ammonia, and methane, trapped deep within the planet. These substances aren't frozen in the way we know on Earth. Instead, they exist in a dense, hot, and fluid state, compressed by the planet's immense gravity and pressure. If you could descend into Neptune, you wouldn't find a surface to land on. Instead, you'd experience a seamless transition from the upper atmosphere into a deep, turbulent ocean of exotic, superheated fluids, with no clear boundary between air and liquid. There's no shore, no solid ground, only a thick, soupy mix of swirling gases and liquids, all churning above a small, mysterious rocky core buried deep within. Any probe or astronaut venturing too deep would be crushed and vaporized by the crushing pressure and searing temperatures long before reaching the center, making direct exploration nearly impossible with current technology. In fact, Neptune's internal structure is more like a star's than a terrestrial planet's, with layers defined by changes in density and composition, not by a solid crust or mantle. This fluid, ever-shifting nature fuels Neptune's violent weather, driving supersonic winds and massive storms that rage across its atmosphere, making it one of the most dynamic and unpredictable planets in our solar system. To truly understand Neptune, we must let go of our earthly expectations and embrace the reality of its alien, ever-changing environment, a world where the familiar rules simply don't apply. Here, the concept of solid ground is meaningless. Neptune is a planet of endless clouds and storms, with no surface to break the chaos. Neptune is a churning, chaotic world, governed by forces on a planetary scale, and its mysteries continue to challenge and inspire us. Neptune's environment is lethal beyond imagination. At the cloud tops, temperatures plunge to -214 degrees Celsius, cold enough to freeze air solid. Any visitor would be flash frozen instantly, but the real danger is the crushing atmospheric pressure. As you descend, pressure skyrockets, far beyond what any human or machine could survive. The atmosphere is a suffocating, powerful fluid that would collapse lungs and crush bones in moments. Neptune's winds are the fastest in the solar system, reaching over 2,000 kilometers per hour, faster than the speed of sound. These supersonic winds fuel storms larger than Earth, raging for years. Entering Neptune would be like plunging into a violent blender, torn apart by winds, frozen and crushed all at once. No technology could protect us from this world's extremes. Neptune is a true giant, defined by unimaginable violence and power. It's a place where survival is impossible even for a second. This is the ultimate hostile environment. Neptune, like all planets, is a sphere, not by chance, but by the relentless force of gravity. Gravity pulls all matter toward the center, shaping planets into spheres because it's the most stable form. Any bumps or valleys are smoothed out by the planet's own immense mass. Neptune's gravity is so strong it molds rock, ice, and gas into a nearly perfect ball. Rapid rotation gives Neptune a slight equatorial bulge, but it remains fundamentally round. The spherical shape is universal among planets, a direct result of physics. The same laws that shape Neptune also shape Earth and every other planet we observe. Denying Neptune's roundness while claiming Earth is flat ignores the consistency of physical law. Gravity works the same everywhere, sculpting worlds into spheres. Neptune's shape is a powerful argument for the universality of science. The roundness of planets is a simple, observable truth. Neptune's deep blue color is mesmerizing, but it's not from oceans. It's atmospheric chemistry at work. The planet's atmosphere is mostly hydrogen and helium, but a dash of methane makes all the difference. Methane absorbs red light and scatters blue, giving Neptune its signature hue. This is Rayleigh scattering, the same effect that makes Earth's sky blue. Sunlight hits Neptune, methane filters out the reds, and the remaining blue light is scattered back into space. High-altitude clouds of frozen methane add white streaks, tracing the paths of fierce winds. Neptune's color is not a surface feature, but a planetary-scale trick of light and gas. It's a vivid example of how physics and chemistry shape what we see from millions of kilometers away. The blue of Neptune is the color of science in action. Even the most beautiful cosmic sights have rational explanations. Neptune's gravity shapes the outer solar system, acting as a cosmic architect far beyond its own orbit. Its immense mass and gravitational pull influence not just its own moons, but also the paths of countless icy bodies and dwarf planets that drift in the darkness. This powerful influence played a key role in the famous Pluto debate, a turning point in our understanding of what it means to be a planet. For decades, Pluto was celebrated as the ninth planet, a distant and mysterious world at the edge of our solar system. But as astronomers peered deeper into the Kuiper belt, they discovered a vast population of similar icy objects, forcing them to reconsider what truly defines a planet. In 2006, the International Astronomical Union set 3 criteria for planethood. An object must orbit the Sun, be nearly round due to its own gravity, and crucially, it must clear its orbital neighborhood of other debris, asserting dominance over its path. Pluto easily meets the first 2 requirements. It orbits the Sun and is spherical in shape, but it falls short on the third. Pluto shares its orbital zone with Neptune and a multitude of other icy bodies, and its path even crosses Neptune's orbit. Rather than being a lone ruler, Pluto is locked in a gravitational dance with Neptune, moving in a synchronized orbital resonance that keeps them from colliding. In this region, Neptune is the true gravitational ruler, its presence shaping the orbits of Pluto and countless other distant worlds. Neptune's gravity dictates the movement of these objects, orchestrating a complex ballet at the edge of the solar system. This gravitational dominance is what secures Neptune's status as a planet, while Pluto, unable to clear its neighborhood, is classified as a dwarf planet. The debate over Pluto's status isn't about diminishing its importance or legacy, but about refining our scientific definitions to better reflect the physical realities of our solar system. Neptune, by contrast, stays firmly in its lane and defines the lanes for others, setting the boundaries for what it means to be a planet in this distant realm. The relationship between Neptune and Pluto is a textbook example of planetary dynamics in action, illustrating the complex gravitational interplay that shapes our solar system. Neptune's gravity acts as the gatekeeper of the outer solar system, maintaining order among the chaos of distant objects. By understanding Neptune's role, we gain a clearer picture of the solar system's true structure and the forces that govern it. Ultimately, the Pluto debate is really a story about Neptune's immense power and the fascinating dynamics that define our cosmic neighborhood. Neptune's statistics reveal a world unlike any other. A day lasts just 16 hours, spinning faster than Earth despite its immense size. A Neptunian year is 165 Earth years. Since its discovery in 1846, it's completed only one orbit. Seasons last over 40 years each, thanks to its slow journey around the Sun. Neptune is over 17 times Earth's mass and could fit nearly 58 Earths inside. It's the densest giant planet, with a frigid atmosphere at -214 degrees Celsius. Despite its distance, Neptune radiates more than twice the energy it receives from the Sun, hinting at mysterious internal heat. These numbers define Neptune's reality, its rapid motion, immense scale, and profound cold. They transform Neptune from a blue dot into a complex, dynamic world. Imagine a human in the best spacesuit trying to visit Neptune. Survival time, less than a second. The instant you enter the atmosphere, you're flash frozen, crushed by pressure and torn by winds. The suit offers no protection, bones collapse, lungs implode, and consciousness is lost before pain registers. Compared to Venus's slow agony, Neptune's end is swift and total. This thought experiment highlights the gulf between human biology and the violence of the cosmos. Neptune is not a destination, it's a stark reminder of our fragility. Neptune may seem remote, but its scientific value is immense. Its discovery proved the power of mathematics and gravity to reveal unseen worlds. As an ice giant, Neptune is a natural laboratory for understanding planet formation, possibly the most common type in our galaxy. Voyager 2's flyby revolutionized our view, and future missions could unlock more secrets. Neptune's role in the Pluto debate forced us to refine our definitions and think critically about planetary science. Studying Neptune gives us perspective on the solar system's architecture and the forces shaping it. It inspires curiosity, challenges technology, and reminds us how much more there is to discover. Neptune is the frontier, a symbol of how far we've come and how much further we can go.